So to begin with, we're going to start with what we know about exponential graphs to help us graph log graphs. But then after that, logarithm graphs are going to be another parent graph that you just need to know what its shape looks like and how to graph it quickly. So to start off with, would you agree logs are inverses of exponentials? So log base 4 of x is the inverse of y equals 4 to the x. And how do we do inverses? We just switch all the x's and y's. So if I know that the graph of my exponential function has the point 0, 1, and 1, 4, and it has an asymptote at y equals 0, this is the graph of y equals 4 to the x, then I can graph my log graph by just switching my x and my y's. So instead of 0, 1, I have 1, 0. Instead of 1, 4, I have 4, 1. Instead of an asymptote that says y equals 0, we switch x's and y's everywhere. I have the asymptote x equals 0. I can also imagine what would happen if I took that graph and flipped it over the line y equals x. And the resulting shape looks like this. To identify the intercepts, it only has the y-intercept of 1, 0. We've done that. We've labeled it on a graph. We labeled the equation of our asymptote. It does ask for the domain and the range. So the domain, our x values have to be bigger than 0 but not equal to 0. And our range is everything. Now on everybody's calculator, whether you have a new one that has any log base or an old one, the two main log buttons are this button LOG, which is pretty obvious that that's a log button. But you might not have known that this LN button is another log button. And so the next thing we're going to do, and I think you have some space on the page right across on page 378 at the bottom. On page 378, we are going to get introduced and graph this logarithm. And this logarithm is called the natural logarithm. I think it's French. They have L first for logarithm and then N for naturel or something, right? Instead of NL for natural log if it was in English. So LN stands for the natural log. And it is the inverse of that new special number E that we found out. E is so important that they put an extra button on your calculator as a natural log. So when you go to graph a logarithm, I want you to right away go to graphing a logarithm just like you can graph an exponential function. I want you to realize that every base logarithm graph has an asymptote at x equals 0. And that every base logarithm graph has the point 1, 0. I mean, off to the side here, you can imagine right, off to the side. I can imagine my e to the x graph. That was something we did the other day. We graphed our e to the x graph. Every exponential graph has 0, 1, and 1, whatever its base is. So on my natural log graph, and you see that my second point would be e comma 1. And has the same shape as all logarithmic graphs. And you know what's coming, right? We now have base graphs and logarithms. We're going to go to our transformations and do all the transformations with our log graphs, just like we did before. But I hope that by now you're starting to feel like I really get transformations. All right, circle questions 10 and 11.